In this module, we'll look at three interconnected parts of the environmental control system. The pneumatic system inputs hot bleed air from the engines and the optional APU. The air conditioning system processes the air to maintain flight deck and cabin temperature and air quality. And the pressurization system regulates the outflow of air according to the pressurization schedule. The use of pneumatic bleed air for ice protection is covered in the next module. The pneumatic system is controlled from the air conditioning panel on the overhead panel. The bleed 1 and 2 shut-off switches control the positions of shut-off valves for each engine. They are normally on during flight, allowing bleed air to flow into the system. They can be switched off if there is a suspected leak. Bleed status is shown on the engine display, with non-standard bleed selection in yellow as a reminder. Here is a table of bleed annunciations. The bleed control selector signals the pneumatic system electronic control unit, ECU, to modulate bleed flow through the nacelle shutoff valves. All other switches and the duct temperature gauge belong to air conditioning and will be covered in the next lesson. With no engines running, APU bleed air is selected on for air conditioning using this switch light on the APU control panel. But to avoid intake of APU fumes, APU bleed should be selected off before starting engines. Low pressure bleed air from a port on the low stage compressor of each engine is always present. But if this is insufficient, high pressure bleed is added from a port on the high stage compressor. Low pressure bleed is normal in flight, and high pressure is used on ground and at low power settings. An electronic control unit controls operation of the whole pneumatic system and determines when to add high pressure bleed, depending on parameters such as power lever setting and bleed demand. The bleed switch on each side signals the ECU to regulate the high pressure shutoff valve to control the addition of high pressure bleed. The HP shutoff valve has an inbuilt pressure sensor. A check valve protects the low pressure line from overpressure by preventing reverse flow. Mixed low and high pressure air passes through a pre-cooler, then is ducted continuously to the de-icing system with no valves or switches. From the de-icing line, pneumatic air is ducted to pressurize the air stair and aft baggage door seals. The bleed selector switches also signal the ECU to control the opening and closing of nacelle shutoff valves. Pressure and temperature are sensed here and monitored by the ECU. For over-temperature or overpressure or a leak in a duct, the ECU will trigger a bleed hot caution light and will close the nacelle and HP shutoff valves. According to checklist, you should close the HP shutoff and nacelle shutoff valves. Touch the number 2 bleed switch. If both bleed hot lights come on, you'll have a pressurization problem. You should descend to a safe altitude and consider ram air ventilation according to checklist. Bleed air from each wing passes through a wing isolation check valve and is then merged and ducted to the air conditioning unit in the aft fuselage. If the optional APU is running, its bleed air joins the main pneumatic manifold. Finally, the pack flow control and shutoff valve regulates bleed air to air conditioning. The bleed control selector should be at min for takeoff. If not, you get the non-standard bleed annunciation on the engine display. The ECU of the environmental control system has 2 digital channels and 2 backup analog channels. The digital and analog channels are fed by temperature, pressure, flow, and other sensors. Either channel can trigger a bleed hot caution light and close the nacelle and HP shutoff valves. A pack flow control and shutoff valve regulates the combined output bleed flow. With both engines running, the ECU balances bleed flow evenly between engines by regulating the nacelle flow control and shutoff valves. If a digital channel fails, the analog backup will step in automatically, and operation should be normal. But with a double failure of both digital and analog channels on one side, bleed from that side will be stopped by closing the nacelle and HP shutoff valves. Note that the bleed hot caution will not be triggered, and bleed will be set to min for the operational side, regardless of the bleed flow control selector position. However, even with a nacelle shutoff valve closed, the pressure-sensitive HP valve will still regulate for ice protection.